Okay, let's look at section 1.1, which are your basic equation notes. And as you can see, when we talk about equations, we want to talk about finding a solution when we're asked to solve. So your solution to a equation is a value or values for the variable that makes a true statement. So you can see if you're given this equation here, 2x plus 3 is 11, then x equals 4 because 2 times 4 plus 3 is 11. So the goal in solving is to make the left side equal the right side because you have an equal sign. So you just think about common sense where two things are equal, they've got to be left is equal to right. So in order to solve, we need to manipulate the equations to create equivalent equations. We can do this manipulations, and any of these things we do does not change the value of the equation. So you can see there's several things we can do here to create equivalent equations. One thing we can always do, we can interchange sides. So, I don't personally like 5 equals 2x. I would rather make it 2x equals 5. And it doesn't matter because they're equal. So you can always flip-flop sides without changing any sides, without adding or subtracting anything. So that's one thing you can do that does not change the value of the equation. The other thing is we want to simplify each side. Very important. I see mistake after mistake being made with this concept where students will, instead of just adding the 2 plus 6 to get 8, they want to subtract 2 from both sides, subtract 6 from both sides. Well, what you're doing is you're just giving yourself more room for error. So you should always simplify. When you're on one side of the equation, you can just combine like terms. You don't need to do the opposite. Okay, the only time you want to do the opposite to each side is if you want to eliminate something from one side of the equation. So on the right side, instead of moving your x's around, just add those two together to get 3x. So that is a much easier equation to deal with than what we started with. Now, we can also, in step 3, we can add or subtract the same number to both sides, and it does not change the value of the equation. So, I've got 2x minus 7 equals 5. Well, if I add 7 to this side, I've got to do it to both the other side. If I don't, then I've changed the value of what I've started with. Just think about if you had something like this. If you had, just say we make a true statement of 2 equals 2. Well, if I add 3 to this side, in order to keep things equal, I also have to add 3 to that side. So I still have two things that are equal. So don't forget, if you add or subtract something from one side, you've got to do it to the other side. Same thing goes with multiplying or dividing. If I have 2x equals 6, I can divide one side by 2. I also have to divide the other side by 2. And we can look at this right here. If I say, again, 2 equals 2, well, if I divide this side by 2, I've got to do the same to both to keep these things equal. So those are some of the mistakes I see people make is they forget to do the same thing to both sides. So when we look at solving equations, we always want to isolate the variable we are solving for by following these steps here and manipulating the original equation by what we did above. So my personal steps that I believe is, first thing I always want to do is I want to clear all fractions, okay? I definitely want to clear all fractions. Once I've done that, if I have to, then I simplify both sides. I combine like terms if I have to. I remove parentheses using the distributive property. Once I've done that, once I've got it both sides simplified, then I undo all subtraction and or addition. I undo all multiplication and or division, and then I undo all powers, roots, logarithms, etc. Those are the highest ordered terms here. So if you think about solving, okay, solving goes along with the order of operations. Okay, back in the day, we always learned our please excuse my dear Aunt Sally. Well, when we solve, we do the order of operations in reverse order. We undo all subtraction and or addition first. Then we undo the multiplication or division. Then we undo the powers, the roots, the logarithms, etc. Okay, so, just try to follow those steps. Try to follow those steps. So let's look at an example here. I've got 7x minus 4 equals 3x plus 8. So in order to solve for x, think about I've got to get all my x terms on one side, all my terms without an x on the other. So if I want to get my x on the left side, then I want to get rid of this subtraction of 4 by adding, because negative 4 plus 4 is 0. But since I added the 4 to one side, I've got to do it to the other side. Then I simplify. So in theory, this is now a 0 here, and we don't write zeros, so I've eliminated the subtraction of 4 by adding 4 to both sides. Next, I want to take the 3x and bring it over here. Well, in order to do that, I've got to subtract it from the right side. But whatever I do to one side, I've got to do to the other. So if you look here, I subtract 3x from both sides. Simplify, that leaves me 4x. That leaves me 0 plus 12, but we do not write the 0. Still want to get x by itself, and always remember, you're always doing opposite operations. So this is 4 times x. The opposite of multiplying would be to divide both sides by 4. Whoops. Sorry about that. Therefore, x would be 3. Okay, so that's your first example. Now let's kind of look at the next one on the list here, where we have 6 times x plus 2 is negative 4 times x minus 3 minus 4. So we go back to our steps up here. We don't have any fractions to clear, but we must simplify both sides. Remove parentheses, combine like terms. So if I look over here, I use my distributive property. I'm taking my 6 times my x, and plus 6 times plus 2 is positive 12, equals, be careful here with your signs, negative 4 times x is negative 4x, negative 4 times negative 3 is plus 12, and then I still have that subtraction of 4. Now this 4 is not multiplied by this negative 4 because it's not inside the parentheses. So I've removed parentheses. Now I'm going to combine like terms. So on the left side, I have nothing to combine here, but on the right side, I've got 12 minus 4, which is 8. Then I proceed to get all my x's on one side, everything else on the other side. So you can either move the number first or the x first. It doesn't really matter. But if I want to move this minus 4x over to this side, since it's negative here, I must add it to both sides. So I add the 4x here, and I add the 4x here. It doesn't matter where you insert it, as long as you keep the positive sign with the 8, the positive sign with the 12. Combine like terms, and I get 10x plus 12. These two make 0, so I'm not going to write that anymore, and I get an 8. Now I've got to take the 12 over to the other side so I can get x by itself. So I do that, by subtracting 12 from both sides. So I subtracted here and here. Again, I get another 0. So I get 10x. 8 minus 12 is negative 4. Be careful with your signs. So I have 10x equals negative 4. Divide both sides by 10. So those 10s go away to make 1x equals negative 4 tenths. Reduce your fraction to get negative 2 fifths. Okay, now I have not showed checking yet, but don't forget, you to know if you're right or wrong, if you substitute your value back into the original equation, the left side should equal the right side. The fraction I know is going to be a little more difficult. The whole numbers won't be, but that's how you can always tell in math if you're right or wrong. Okay, so let's go to the back. And if you notice on the back here, let me scoot my camera around. I'm new at this, so bear with me. We have a fractional equation. Okay, that's one of the F words in math, fractions. I know fractions make us nervous, but learn how to deal with them, learn how to eliminate them, and you can be successful, because this is nothing more than division. This is x divided by 6 plus 2 divided by 3 is 3 divided by 4 and then times x. Now this x is also multiplied by the numerator. It's not in the denominator. So what we want to do is step 1 of our solving, and that is to clear fractions. So what we want to do is we want to find least common multiple of 6, 3, and 4. So what number is a multiple of all 3 of these and is the smallest one? Well, 12 is a multiple of 6. 12 is a multiple of 3. If you think about it, 6 times 2 is 12, 3 times 4 is 12, and 12 is also a multiple of 4. And it's the smallest. So your LCM then is 12. Now, what I want to do next is to multiply both sides by 12, because I want to clear my fractions. In order to get rid of division, we must multiply. But if I multiply one side by a number, I've got to multiply the other side by that same number. If I multiplied here by 6, then I'd get rid of the 6 and the 3, but not the 4. So you got to make sure you're multiplying by something to eliminate all items. So I go ahead and I take 12, and you can put it over the 1 if it makes you feel better. That kind of lets you know what goes where. So I multiply the left side by 12, and then I multiply the right side by 12. Okay. Now see, I've got to distribute 12 times this, both of those terms, and 12 times those other terms. So now I distribute. And normally what I found throughout my years of teaching is most people are pretty good with these first 3 steps. It's the execution of this next step. So I take 12, and if you want to use a dot, if that makes you feel better, that's fine also. It's whatever you're most comfortable with. Okay, so I've distributed. I've taken 12 times this term, 12 times this term, 12 times that term. Now, several ways to do this. Think about reducing your fractions. When you're multiplying 2 fractions together, you can reduce any numerator with any denominator. Well, there's nothing to reduce here because that's a 1. But see, I can reduce this 12 and this 6. But here's the mistake people make. They forget to eliminate the denominator when they're reducing. So if I want to reduce the 12 and the 6, I can take a 6 out of the 6 and a 6 out of the 12. I'm dividing both of these by 6. Or you can also look at it as what's 12 divided by 6? Well, it's 2. But just make sure you get rid of that 6. So you're just reducing fractions. And what you have left is the 2 times the x. Now I go to the next term. I can also reduce a 3 from here and a 3 from here. And that leaves me with a 4 up here. Sorry about that. So what I'm left with is 4 times 2, which is 8. Over here, I can reduce the 4 by itself and the 12 by the 4. And I'm left with 3 times 3 times x, which is 9x. So I have this. This is the step where most people fail. Okay? So, just make sure once you're done, if you notice here, I have all 1s in all my denominators. So that means that it's 2x over 1, 8 over 1, 9x over 1, but we don't write that. We just write the 2x, the 8, or the 9x. So now I'm still solving. What I'm going to do next is I'm going to interchange sides just because I know I need to get my x's on one side. I prefer to do that. You certainly do not. It doesn't matter. You can certainly take the 2x over to that side. I just like my x on the left side. So I interchange sides, then I subtract 2x from both sides to take this 2x over here. This becomes a 7x, this becomes a 0, and that's an 8. Then I divide both sides by 7 to get x equals 8 sevenths. Okay? So, don't be afraid of the fractional equations. Don't be afraid to try them. Just go ahead and get it done. Figure out how to do it. All right, so now let's work on the next example here. And we are now solving another fractional equation. We've got 1/2 times the quantity x plus 5 minus a 4 is 1/3 times the quantity 2x minus 1. Now, one thing you can do here to maybe make this look a little bit better is you can take just x plus 5 because this is a grouping symbol, this fraction bar. So I've still kept this grouped, and when I'm multiplying by 1/2, it's the same as dividing by 2. And I can do the same thing on the other side. I can take the 2x minus 1 over 3. Now, once we do that, we are still clearing our fractions. So I need to know the least common multiple of 2 and 3, and that is 6. 2 goes into 6, 3 goes into 6. And if you're never quite sure, you can always multiply your denominators together. But sometimes if you do that, it won't be the least common. You'll just end up with bigger numbers. It's okay. You'll just have to reduce when you're done, but it's okay. So let's now multiply both sides by 6. Okay, so I'm going to take 6 times the left side and 6 times the right side. And again, you can put it over 1. And what happens here is this starts looking a little bit bad. Because you've got these x plus 5 and 2x minus 1 are your numerators, but don't let it freak you out. Just, just remember this is one fraction, and that's a whole number. That's all it is. So, don't freak out. Don't give up. Just execute. So I'm going to distribute here times this, distribute this times this, and do the same thing on the right side. So now I distribute, and I'm going to take 6 over 1 times x plus 5 over 2, and I'm going to take plus 6 over 1 times negative 4 equals 6 over 1 times 2x minus 1 over 3. So here again is the problem area. So I'm going to divide the 2 by the 2 and the 6 by the 3. Keep in mind, when you do that, you've got 3 times x plus 5. Take the 6 times the negative 4 to get negative 24, so there's really nothing to reduce here. And I'm going to reduce both of these, 3 by 3, 6 by 3 to get my 2. So once I've done that, now I'm taking the 3 times the x plus 5. It's got to go back inside parentheses because that fraction bar was a grouping symbol. I get 6 times negative 4, which is negative 24. And then I'm going to take the 2 times the 2x minus 1. So that's all just the first step of solving, is to clear your fractions. It's the hardest step, I know, but you can do it. So I go back to step 2, simplify both sides. I distribute the 3. I distribute the 2. Combine like terms here. 15 minus 24 is negative 9. Now I can either move the 4x over or the 9 over. It doesn't matter. But if I choose to get rid of this 9 here, I've got to add 9 to both sides. Watch your signs. This is my 0, so I don't write it. Negative 2 plus 9 is positive 7. Now I need to bring the 4x over. So I subtract 4x from both sides. Now this right here is negative x or negative 1x. They mean the same thing. I know most times they'll leave it as minus x, but you can certainly put a minus 1 in front of there if it helps you out. Over here is a 0 plus 7, which is 7, but I have not solved for x yet, so I must divide both sides by negative 1 to get x is negative 7. So it's a lot of steps, but you just got to take your time. Make sure you execute each step. Watch your signs. Math is all about paying attention to detail, so don't forget the details. And what happens is as we move on, we get more and more complicated type equations. And so this next equation here, we now have an x minus 4 in our denominator. Well, that's just one number, okay? Even though you have two terms here, it really represents one number, because once we know x, we're going to subtract it, and it will end up being one number. Now, there is a problem here that you have to keep an eye on. Anytime you have an x in the denominator of a fraction, you have to be careful about getting 0. Because if we get any fraction with 0 in the denominator, that's what we call undefined, because you cannot divide by 0. So in this case, we have to be careful that when we get a solution, whatever value we get for x, once we substitute it in, it cannot be 0. So if you think about what x would give me 0 in the denominator, I know right now x cannot equal 4, because 4 minus 4 is 0. So we're going to go ahead and solve this. If we get anything but 4, we're okay, as long as it checks. If we get a 4, we know there's no solution to this particular equation. So I have, as far as my denominators, I have x minus 4 and x minus 4. The least common multiple of that is just the x minus 4. Okay, again, that's one number. So then I multiply both sides by x minus 4. And you can treat it the same way as you do your numbers. You can take it, whoops. Didn't mean to put that dot there. So now I'm going to take the x minus 4 over 1 times 2 over 1. I'm going to take my x minus 4 over 1 times 5 over x minus 4. And I'm going to take my x minus 4 over 1 times x plus 1 over x minus 4. Now, as I look through in this first term here, they both have 1s. There's nothing to reduce. In this second term, I have to reduce the entire x minus 4 if I can. You cannot just cancel out the x's. It has to be the whole thing because of the minus sign. But I can take x minus 4 divided by x minus 4, and that just gives me a 1. I can do the same thing here. I can divide the x minus 4 by the x minus 4, and I get a 1 there. So if you look at, I have all 1s, which means I have cleared my fractions. Now I've got to multiply what remains. And you can do that. And you can take the 2 times the x minus 4. I have plus 1 times 5. And I just have 1 times x plus 1. And don't forget, you still have to group these because they were in a grouping symbol over here. That's why we changed from the fraction bar to the parentheses. Now I go back to my step 2, and I simplify both sides. Combine like terms here. Negative 8 plus 5 is negative 3. Add 3 to both sides. Subtract a 1x, because don't forget that is a 1x. And I get x equals 4. From what we've done, we say x equals 4. But when we started this equation, we know right here. X cannot equal 4. So since we ended up with 4, we can say there is no solution. Okay? So, you know, when you're dealing with equations, you just got to remember the steps. Go in order of the way I'm showing you. Execute the step where you are reducing your fractions. Very important to execute that step there. And then always check to make sure your solution is valid. And also check to make sure it's the correct solution. Okay, you can always substitute your numbers back into the original equation to check on those solutions. That'll be it.